Good morning, students. Welcome to Chandra Higher Secondary School. I think this is your first video lecture of your physics of first year students. So welcome to all of you to this class. So in this class, let us discuss something about first physics. I think some of the students of you fear about the physics, how the physics is very hard. No. That should not be there. Physics is quite simple and easy if we will involve in it. That is a very important point. If you love one subject, then the subject will love you. Clear? So, first of all, we have to know what is physics. So, everything around us, what we have seen here, everything around us that belongs to physics. Everything, whatever I am talking, that is also a part of physics. Okay, I am writing, that is also a part of physics. Okay, I am standing here, that is also a concept of physics. So everything around us belongs to physics. So that means physics is in our everyday life. Okay, so basically if you will go to the normal formula or a normal definition actually of physics, then what I will say? Now, physics is a branch of science which deals with the matter and the motion of the matter. This is a very important point. It deals with the matter, different types of matter, whatever the matter is in our surrounding, and its motion of the matter in our surrounding. So that is the thing we deal with generally in physics. So in this session, this is the most basic thing we have discussed, and in physics generally we are discussing different concepts about the energy we are dealing with around us. What are the, because I am doing some work means I have some energy. Clear? So what are the energy around each other? What are the concept of energy? How the energy generated? Okay, so these things we have discussed in physics basically. So here there is written, I have go to the chapter number 2. If I will go to the theory or if I will go to the subject directly in your 11th class or in the first year of physics, this is the chapter number 2. The chapter number 1 is actually physical world. That means whatever we deal with in everyday life that belongs to your physics, that thing we have just I told you. So in the chapter number 2 we are dealing with, that is unit and measurement. The part 1. Okay, this is the part 1 of the chapter number 2. The part 1 we are dealing with unit and measurements, and what are the different things, what are the different parts we are dealing with in units and measurements. That is an important point. Okay, so first of all let us know what is measurement, what we will measure, how we will measure, and why we will measure. These are the 3 points. Okay, we are concentrating on. So first of all, let us discuss about what is measurement. So students, if we are doing some experiments, if we are doing some research work, okay, so in all experiments and all research works, measurement is the primary basis. Remember that one. Because without measurement, you cannot perform any research work or any experiment. Clear all of you? Okay, that means whatever the things we are going to research, whatever the things we are going to do experiment in the lab, clear, that base is upon the measurement. Clear? Okay, so now the quantities which we will measure directly or indirectly. Okay, the quantities which we will measure directly or indirectly, that type of quantities are called physical quantities. Okay, remember that is one. So physical quantities, for example, if I take an example, the length, mass, okay, then your time, velocity, volume, these are some of the examples of your physical quantities. Whatever the things, that means suppose length. Okay, so length is a physical quantity by which we can measure the length of any object. Clear? And one very important point I have to mention there, that is, these are the quantities which we can measure directly and also indirectly. Indirectly how? For example, suppose I want to measure the length of the distance from Earth to the Sun. Can we measure it directly? No, it is not possible. So we have to measure it indirectly. That is a very important. So the quantities which we can measure directly or indirectly, that quantities are called, all these quantities are called physical quantities. And just I have given the example, that is your length, that is your mass, that is your time, that is your velocity, volume, etc, etc, etc. Clear all of you? Okay. So now this is some of the things about the measurement and the physical quantities. Physical quantity, this thing we physically do this. Suppose this is your marker, and why I want to measure the length of this marker. What is the length? What is the length of the marker? That means it can be done physically, obviously. So that's why it is a physical quantity. The length is a physical quantity. Very simple. Okay. So now next, in order to measure the physical quantity, the value must be compared with the standard value. Remember that one. Okay. In order to measure the length, in order to measure the value of a physical quantity, this may be length, this may be mass, anything. So in order to measure the physical quantity, I have to compare it with a standard value of the same kind. Remember that. That means I have to measure the length, or I have to compare the length with the length only. I cannot compare the length with mass. I cannot compare the length with time. Okay? Because these two are two different physical quantities. Time is a different physical quantity. Length is a different physical quantity. Okay? Remember that is so. In order to measure any physical quantity, okay, it should be compared with the value or with the standard value of its same kind. Okay, so that standard value is known as unit. Clear? Whatever the standard we have taken, that is called unit. Remember that is for example meter. Very simple. Meter is a unit of length. Similarly, kilogram, it is a unit of mass. Similarly, second is a unit of time. Very simple. Okay, so that means whatever the units, for example meter, kilogram, second, these are the standard things, okay, which will be compared with the normal physical quantity. Suppose I have to supply it with a stick. Suppose this is your stick. This is a stick supplied with me. Okay, and what I have to do? Now I have to find out the length of this stick. Very simple. That means I don't know what is the length of the stick, but to find out the length of the stick, what I have to do? Now I have to compare this with a standard value, with a standard thing. Okay, so standard thing means I have to supply it with a measuring device. It is either a measuring belt or it is either a measuring stick, and that measuring stick is a standard value. Very simple. For example, a scale. Suppose I take an example of a scale. Okay. Generally, I think in the market the length of the scale either 15 centimeter or 30 centimeter. You cannot find out a scale having 16 centimeter. Can you find out in the market? No, because this is the standard thing. When you go to the market to purchase a scale, the scale length, the standard length of the scale becomes 15 centimeter or 30 centimeter. Clear? Okay. So I have to bring the device. Then I have to put it here and measure the length. Very simple. Okay. Then suppose after measuring with a scale or after measuring with a measuring device, standard measuring device, what length I will get? Suppose I will get 4 centimeter. Let I will get the length of the stick become 4 centimeter. That means this 4 centimeter is what? Now the 4 centimeter is my value. Which value? Length of this stick. Clear all of you? Okay. Now, it's a very important thing. Look at here. During the measurement, very important thing. Look at here. During measurement of this object, whatever object I will take here, I will get two things. What are the two things? One thing is your number. Another thing is your unit. Look at here. Okay, the first thing is a number and the second thing is the unit. Okay, come to the second thing, unit. What the purpose of unit? Just I told you, the purpose of unit to compare it with a standard object. Okay, like a scale. Clear? Okay, so that means the second thing, that means the unit, is used to measure or to compare this object, the given object, with a standard object, with a standard thing, standard measuring device. And come to the first one, that is the 4. Okay, so 4, what the 4 gives us? Now 4 gives us the number of times. Okay, how the number of times it will increase from the comparing length or decreasing from the comparing length. That is, for example, suppose I will get, very simple, I will take a measuring device scale which is generally your 15 centimeter, very simple. Okay, and here suppose I will get 4 centimeter length. That means approximately, look at here, approximately this 4 centimeter gives me that using this scale, this is your scale, look at it, this is your scale. So using this scale, I have to measure this device. Okay, so using this scale. So now, what conclusion from these two I will get? That means the given stick is how many times lesser than this one? Approximately 3 times. Approximately 3 times. This measurement of this object is approximately 3 times lesser than this standard scale. Very simple. Okay, so remember that means during the measurement we will get 2 things. One is a number, another is a unit. The unit gives me or helps me to compare this with a standard measuring device. Okay, and this one, that is the number, gives me how many times the value or the standard value increases or how many times the standard value decreases from this original standard device or object. For example, scale. Clear all of you? Okay, so now these are some of the discussion. Next, there is a question in my mind that, or I think in your mind also, that unit, that means suppose my name is Babu. Okay, that means I am recognized with my name, very simple. Okay, that means to recognize the unit of any physical quantity, a good unit, there are some properties by which you can recognize that unit is a good unit or qualitative unit. It is a very important one. So what are these properties? The basic properties of a good unit or a qualitative unit becomes the first one. Listen very carefully. What are the properties? The basic properties. The first one. It should be well defined. It should be well defined. That means meter, okay, is the unit of length. So the unit of length, meter, should be properly defined, so that we can directly, or anyone blind people can also directly find out what is the unit of length. Very simple. Okay, so the first property is your well defined. The first basic property of a good unit or a qualitative unit, well defined. Number 2 is a very important one. Number 2, easily accessible. Easily accessible. That means this whatever the unit I will take, that unit must be easily accessible by all the person or in all the experiments. Okay, easily accessible. So number 1 is your easily accessible. Okay, then number 3 is a very important one. The unit must be accepted by all. Okay, the unit must be accepted by all, so that everyone can use this unit qualitatively. Clear? Okay, this is number 3. Number 3 is your easily accepted by all. Okay, number 4 is invariable. Okay, invariable. So what do you mean by invariable? That means suppose meter is the unit of length. After 6 hours, can the unit of the length become kg? No. That means the length or the whatever the unit of length, that should be invariable, that should not be varied apart from the situation, apart from the person, apart from the experiment. Okay, that means whatever the unit is fixed or whatever the unit is defined for a physical quantity, that unit must be constant, invariable. That should not be variable. Clear? So these are the most physical or fundamental properties by which we can easily call the unit as a good unit or as a qualitative unit. Clear all of you? Okay. Now next let us talk about types of units. Okay. Next let us discuss about some of the discussion about types of units. So generally unit basically 3 types. The first one is your fundamental unit. Second one is your derived unit. Third one is your supplementary unit. Okay, third one is your, again I have to write, supplementary. Okay, the first one is your fundamental unit, second one is your derived unit, third one is your supplementary unit. Clear? So let us talk about the fundamental unit. Okay, so fundamental unit means these are fundamental or basic type. That means these things are depend upon this, but this is not depend upon this. It is the individual one. Okay, so the units which are basic and which do not depend upon other units, they are called fundamental units. Clear all of you? So there are how many types of fundamental units? Now there are 7 types of fundamental units. Remember that one? There are 7 types of fundamental units. Let us talk about the 7 types of fundamental units, which are very important. Let us discuss about the 7 types of fundamental units. Okay, number 1 is your mass. Okay, number 2, mass is a fundamental unit. What is the representation or what is the unit? Remember, this is the physical quantity, mass. Okay, so what is the unit? Kilogram. Okay, and what is the notation? A kg. This is the first one. The second one is your length. Okay, meter. Symbol is M. Third one is your time. This is your second. You can write down. Yes. Clear? Number 4, mass. Remember, mass, length, time. These are the most basic fundamental units which are used in our day-to-day life. Clear? The next one is your temperature. The next one is your temperature. Unit is, basic unit is Kelvin. Basic unit is Kelvin and its notation becomes K. The temperature is also called thermodynamic temperature. Then fifth one. So this is your temperature. Remember, mass, length, time, temperature. Next is your electric current. Electric current, ampere, symbol is A. Then sixth one, luminous of intensity. Luminous of intensity, candela. Unit is candela, and the short form is CD, or abbreviation becomes CD. Clear? Then the last one is your amount of substance. The last one is your amount of substance. Clear? Unit is mole, and in short form it is written as mole. Clear? So these are the most fundamental units. Clear all of you? Mass, length, time, temperature, electric current, luminous of intensity, and amount of substance. Clear? The mass is having the unit kilogram, in short abbreviation kg, length becomes meter m, time becomes seconds, temperature having Kelvin, K, capital K, notation is capital K, electric current ampere, capital A, lumination of intensity candela, and it is the notation is CD, and amount of substance become mole. Okay, the unit becomes mole, and in short it is write down MOL. Clear? So these are the most fundamental basic units. You know what this is? That means with the help of these 7 units, we can derive or we can find out other units. That's why these 7 types of units are called fundamental units. Clear? So these are about the fundamental units. Now next we have discussed about the derived units. Okay, the second type is your derived units. Clear? So as the name defines, derived units, that means the units which are derived from the fundamental units, these are called derived units. Very simple. Okay, for example, let us take an example. So these derived units are derived from the fundamental units. Okay, so let's take an example, very simple example. Suppose I will take velocity. Let us take an example, velocity. Okay, so now let us verify whether the velocity is a derived unit or not. Okay, so velocity, as all of you know, velocity formula or velocity can be defined as, very important, velocity can be defined as, that is length, or we can write displacement covered divided by time. Okay, so look at here. So velocity is equal to displacement covered. Displacement covered means what is the fundamental unit length? That's why I mentioned here length. That's what this is time. So that's simply, look at it. That's simply. So length, what is the unit? L. Okay. Length. Suppose I take a notation L, and this is your time. So for the length L, what is the unit? Basic, more fundamental unit, na meter. The simple thing is meter. So let us take meter. Okay. And for time, what is the unit? A second. So that's why this is your meter per second. Clear? So now look at it. So velocity is not a fundamental physical quantity. velocity is a derived physical quantity, because here we have proved that the velocity can be represented in terms of the fundamental physical quantity. This is the length or displacement component, this is the time. So length, suppose the notation I will take L, and time, this is T. So what is the unit of length? L, meter. What is the unit of T? That is your time. That is the second, meter per second. That is it. So velocity meter per second. Okay. Another let us take an example, very simple example, acceleration. Okay, acceleration. So acceleration is equal to, again it is velocity divided by time. Look at how it will convert it. How it will be converted, look at here. So velocity divided by time. So velocity already I got it. So velocity is nothing but a meter per second. Already I proved here. And time is again your second. So that means this should be meter per second square. Clear? So these are some of the examples of your derived units: velocity, acceleration, force. Okay, so these things are derived physical quantities, and these units are called derived units. Remember, velocity, acceleration, these are not units. Velocity, acceleration are the derived physical quantities, because these can be represented in terms of the fundamental physical quantity. Just I have discussed. So what are the fundamental physical quantity? The mass, length. Just I have discussed 7 fundamental physical quantities, and these fundamental physical quantity has or having the fundamental units. Clear? So now what are the given examples I have here? Velocity and acceleration or force, etc., etc. These are your derived physical quantities, and these derived physical quantities, whatever the units I have derived here, that is the derived units of derived physical quantities. Clear? Okay. Now let us talk about the last one, that is the supplementary units. The third one, that is your supplementary units. Okay, the third one is the supplementary units. Generally in physics, we have 2 supplementary units, remember, and these actually, if we define the supplementary unit, then what does it mean? As we know that, suppose we are given an exam. Okay, we got a paper right now. Then after finishing of this main paper, what I will want from the examiner? I will want some supplementary set. Similarly, the supplementary units also the supplementary units also helps the fundamental unit to derive the derived units. Remember, so supplementary units act like a supplement. Supplementary units act like a supplement. With what? Now with the fundamental units to get the derived units. Understood? There are generally 2 supplementary units. Okay. One is your angle. Okay. Another one is your solid angle. Clear? Okay. Now the angle, this is notation is your radian. Okay, and this is the notation is your steradian. These are the 2 supplementary physical quantities. Generally the supplementary physical quantity belongs to these 2. First one is your angle, second one is the solid angle. Okay, the angle is having unit radian, and the solid angle is having unit steradian. Remember that is. Okay, so now suppose let us discuss about the first one, that is your, let us discuss about the first one. Let us discuss about the radian first. Okay, so now look at this example. Okay, suppose this is a part of a circle. It is not a part of a sphere, it is a part of a circle, two-dimensional structure. Okay, so this is a part of a circle. This is the arc. Suppose arc A, very simple, I name it as arc A. This is the angle theta. And the length, suppose this length I will take it as r, very simple. Okay, so now this is the explanation of the radian. Okay, so radian, this is the angle which is generally used to measure the angle of a two-dimensional structure at the center. So this angle I have to represent in terms of radian. So what is the value? The theta is equal to, so very simple, arc A, the length of arc A divided by r. Suppose let length of arc A is equal to L, then this I can write, this is L divided by R. So this is the explanation of this is the expression of your angle, or simply I can write it here, this angle also I can write it here, plane angle, same thing. This is not a plane angle, this is a solid angle. Okay, clear? And this angle I present in terms of L by R. Arc A, this one divided by this radius. Clear? Now come to the solid angle. Okay, solid angle, remember, solid angle is used in case of three-dimensional structure. Okay, that means I have to take a sphere. I cannot take a circle, I have to take a sphere. So look at the figure very carefully. Okay, I think all of you visualize that one. So this is a part, some part of a sphere. Look at this, and this is the angle. This is the center angle. Okay, of a which, and this is my surface. Clear? Okay, so this is my surface. Suppose the area of the surface I will take del A. So let the area of the surface I will take del A, and this angle is denoted as steradian, and steradian the notation become omega. Clear? Okay, and this is simply theta notation. So now what I will write, remember, suppose this is the length becomes r, and this I will notate is become omega. So now this omega is your steradian angle, which I have to find out in case of only three-dimensional structure, for example sphere. Okay, so this is equal to this area, okay, divided by the square of the radius, r square. Remember, this is my expression of which angle? The steradian. This is the expression, or this is the formula by which we can find out the value of this steradian. Clear? So this is, remember, this is the value, or this is the formula by which we can find out the plane angle. This is the formula by which we can find out the solid angle. Here the unit, this unit is your, this angle unit, or the plane angle unit is your radian, and this plane angle unit is your steradian. The notation is theta, and here the notation become omega. Clear? Thank you so much.